Hi guys, in this video I'm continuing to solve a NUFYPET Math specimen for the year 2021 and I am covering questions 11 to 15. In question 11 we are given two simultaneous equations. The first equation is quadratic and the second equation is linear, right? We don't have any quadratic terms or any roots here, so it's a linear equation. What is the value of y when x is greater than or equal to 0? The substitution method is the most obvious to use here. We will express y in terms of x from the second equation, this one here, and we'll substitute this into the first equation. Alright, now let's rewrite the second equation, which I marked with an asterisk as y equals 2x minus 5. Let's mark it as equation 1, and I'm going to substitute this equation into the quadratic one, the first equation. That gives me 4x squared plus 2x minus 5 squared plus 10 times 2x minus 5 equals 47. So that gives me 4x squared plus another 4x squared minus 20x plus 25 plus 20x minus 50 equals 47. I can already see that something is going to nicely cancel out. That's minus 20x and 20x. And the equation therefore becomes 8x squared equals, so 25 minus 50 is minus 25, and if we take it to the right hand side with a positive sign, that gives us 72, right? Let's double check. Yeah, that's 72. Okay, so x squared is therefore equal to 9, and x equals 3 in this particular problem. So we are taking here a positive value because it was specified in the question that x must be non-negative. Okay, now we're ready to come back to the equation 1 and find the value of y. So it follows that y equals 3 times 2 minus 5, 1. And this corresponds to answer D. Question number 12. 5 runners competed in a race: Fred, George, Hermione, Lavender, and Ron. It is known that Fred beat George, Hermione beat Lavender, Lavender beat George, and Ron beat George. Assuming there were no ties, how many possible finishing orders could there have been given only this information? So this is the combinatorics problem. We have 6 possible answers. And to solve this question, I'm going to use the method of successive operations. If there were no restrictions on who beats who, then we would have simply said the first winner can be chosen in 5 ways, the second winner can be chosen in 4 ways, the third winner in 3 ways, and then 2, then times 1, and altogether we would have had 5 factorial ways of rearranging the winners if the conditions were not specified. But since there are restrictions, we need to consider separate cases. We begin by noticing that at least 3 participants beat George. Fred, Lavender, Ron beat George. Hermione beat Lavender, which implies, together with the third condition, that Hermione must have beaten George as well. So I can conclude that all 4 participants beat George, and he will be in the 5th place. Now let's go back to place 1. Who could be there? Could it be Fred? Potentially, yes. Could it be Hermione? Yes. Could it be Ron? Yes. But could it be Lavender? From the second condition, we can say that no, Lavender cannot be in the 1st place, right? Because Hermione must beat Lavender. So I'm going to exclude Lavender from the 1st place, but it is possible that Lavender could be in the 2nd place, right? So Lavender could be here. Now, how many options do we have for the 1st place? it's the Hermione that beats Lavender, right? So we have only one possibility here, only one choice. So it will be Hermione on the first place. We have Lavender in the second place. After we've removed Hermione and Lavender, we have a choice of either Fred or Ron for the third position, right? So we have two possibilities here. And after that, we are left with only one choice. Okay, and one choice, the last person is George. So that gives me two possibilities. I'll write here to make clearer that this is Hermione here. Okay, now what happens if we put Lavender in the third place? Now the choice of a first place is not limited to just Hermione, right? Because she could be in the second place and still beat Lavender. This means that we can choose either Fred, Hermione, or Ron for the first place. Then two choices for the second place. And one choice, remaining choice for the fourth place. Equals 6. But within the 6 combinations, we must exclude the ones that have Hermione after Lavender. So it will be the combinations when we have either Fred in the first place or Ron in the first place. So there are two such combinations. And therefore, when Lavender is in the third place, we have 6 minus 2, we have 4 possible combinations. So we've got 2 combinations from the first case, 4 combinations in the second case. Let's mark them. Case 1, case 2, and there is a third case when Lavender is in the fourth place. And in this case, clearly we don't have any limitations because everyone beats George and Hermione can take any available place. So we have 3 choices for the first place, then remaining 2 choices for the second place, and the remaining 1 choice for the third place. And the number of combinations is 6. And the final step is just to add all of them up. That will give me 2 plus 4 plus 6. The number of combinations is 12. This corresponds to option C. Next one is question number 13. We need to simplify the given expression. The first immediate thing that we could do is to get rid of x squared in the numerator and the denominator. Now the numerator of the expression we're left with can be factorized, but I need to have 4x minus 1 in the numerator so that I can cancel it out with the denominator. So what I'm going to do is I'm going to change the sign after 4 from minus to plus. Okay, and I'm going to swap the positions of 1 and 16x squared. So that will give me 4 plus 4x minus 1 times 4x plus 1 and 4x minus 1 times 2x in the denominator. 4x minus 1 will be cancelled out and we're left with the expression 4 plus 4x plus 1 over 2x, which becomes 8x plus 4x plus 1 over 2x. This is 12x plus 1 over 2x, which can be simplified to 6 plus 1 over 2x. This is option F. Okay then, are we ready for question number 14? Which of the expressions below has the largest value for x greater than 0 and less than 1? I'm going to solve this problem by considering each option in turn. So for option A, we have 1 divided by the number which is greater than 0 but less than 1. And we should remember that if we divide 1 by something that's positive but less than 1, for example 0.1, the resultant number will always be greater than 1, right? Now, option B, we are squaring a very small number between 0 and 1, and the result will be that x squared will be less than x, right? And if we compare options A and B, then it's clear that we can disregard option B immediately. Okay, then for C, we have 1 divided by 1 plus a small number. Take a look at the denominator. X plus 1 will be a number between 1 and 2, right? And if we divide 1 by a number that's greater than itself, the result will be less than 1. So again, comparing this with the option A, we can exclude this possibility. Next one, let's think now about E, square root x. When we take square root of x, and x is the number between 0 and 1, the resulting number is actually larger than x. If you're not convinced, think about the square root of 0.04, which is 0.2. So square root of x will be larger than x, but it will still be less than 1. So it means that we can get rid of the option E. And now let's think about the last option, D. When I discussed option E, we made the conclusion that x is less than a square root of x. Now, what happens if I divide 1 over root x? How does this number compare with 1 over x? So we said that a square root x is larger than x, so I divide 1 over larger number and compare it with 1 divided by a smaller number. And it is clear then that 1 divided by a smaller number is greater than 1 divided by square root x. Therefore, we can make the conclusion that the largest value is 1 over x. This is option A. And the last question, question on trigonometry. The diagram shows a quadrant of a circle centered at O with radius 20 centimeters. The chord AB has been drawn. So the chord is a straight line, AB. What fraction of the quadrant is shaded? By fraction, we mean the proportion. Or what is the ratio of the area of the shaded segment to the area of the whole sector? So this whole thing, AOB, is called a sector. The shaded region is called a segment. So we need to find the ratio of the segment to the area of the sector AOB. The area of the segment is found by taking the area of the sector, right, AOB, minus the area of the right triangle AOB, divided by the area of the sector. So this is effectively 1 minus area of the triangle AOB divided by area of the sector AOB. The area of the triangle AOB, this is the right triangle with the angle 90 degrees, which is the same as pi over 2 radians. So the area of the triangle is half times radius squared, 20 squared. And the area of the sector is half times radius squared times the angle that subtends the arc AB. So this arc AB. And this angle is pi over 2. You could also find the area of the quadrant by taking a quarter of the area of the circle. Okay, so now some of the terms get cancelled out. And therefore we get 1 minus 1 over pi over 2. And now we need to simplify it into a single fraction. This is the same as 1 minus 2 over pi. And we can then rearrange this into pi minus 2 over pi. And this clearly corresponds to the option C.